Good evening, and I welcome you students for another very important and amazing session on the chapter of the light reflection and refraction. Last time we have introduced to you what are spherical mirrors, and we have also shown you what type of image is formed by a plane mirror. Plane mirror is the mirror which you are using for combing your hair at your home, And what type of image is formed in the plane mirror? You have already seen the image is virtual, erect, and of the same size. And how to draw a diagram? We told you that actually what happens is that when light is falling on the object, and if I place a mirror, plane, concave or convex, what will happen? There will be rays of lights will be reflected from every point, and they will form an image. But the formation of image in plane mirror is simple because it is virtual, erect. But when I will use spherical mirrors, the interesting thing is if I use concave mirror, then the concave mirror can form different type of images: real, inverted, virtual, erect. The size of the images can also vary. So how do we find out what type of image will be formed when we have an object placed in front of the concave mirror? This will depend on the distance of the object from the concave mirror. As I will change the distance of the object, we will also see different type of images which will be formed. And that is our topic today, that how do we represent images formed by spherical mirror? What trick we can use? What rules can be applied for the formation of images? But we said very clearly that the formation of images by spherical mirrors can be done by using ray diagrams. What will we use? Ray diagrams. So we should practice what I am saying, ray diagram. How about images formed by spherical mirrors? How can we locate the image formed by concave mirror for different positions of the object? As I said, what I am trying to tell you, this is my concave mirror. You know about it. Try to practice it. I'm not so good at drawing, but student, you try to practice and draw these images. The more you draw, the better you will be. You can use a scale, and with a scale, if you know that if this is 2 centimeter distance, then you take another 2. So if I take this distance, what I'm trying to say, student, if this distance, how will you draw? Take a scale. If this distance is 2 centimeter, from here to here, that is your focus. Then you draw another 2 centimeter. This is your center of curvature. This is your pole. So draw a line. With this line is called the principal axis, we told. Now what we are saying, let us take an object. You can stand yourself before a mirror, but you are big. We will take some objects like this. Supposing this is my object, student. When I take an object, I am using an arrow, as you can see. This is the head of the object, and this is the bottom, the tail of the object. And we always try to draw ray diagrams. What we are trying is to draw the ray diagrams in order to find what type of image will be formed, where it will be formed, what will be the size of the image by using the ray diagrams. And we will use mostly, you will see the ray diagram will be constructed from the head. And what will be need, student, for drawing the ray diagrams? We will choose always there will be a need of the 2 ray diagrams. What we need, although there are infinite number of rays originating from each of these points. If I take this point, this point, this point, this point, so when the light is falling on this object, there are infinite number of rays. But to construct the ray diagram and to locate the image of an object, it is convenient to consider 2 rays. What we will consider? 2 rays. And the point of intersection of the rays, will be the point where image will be formed. How many rays I will use for drawing the ray diagrams? 2 rays. I will not take large number of rays. That will make our story easy and simple. The interaction of at least 2 reflected rays gives the position of the image. Note down, these points are important. What we are saying, I will take, whenever I want to draw the images, if I want to draw the image is formed by spherical mirrors. It could be concave or convex. First, I am taking concave mirror. Images formed by spherical mirrors. Here, I am taking concave mirror, student. From each of the point, there are infinite number of rays. But how many we will consider? But we are going to consider, student, 2 rays. So we will use 2 rays. Okay? Then 2 reflected rays, 2 rays which are reflected rays. 2 reflected rays I will use. And I will be using the head. This is the head and this is the tail, the bottom. So we will take the 2 rays from where? From the head. Second point, the point of intersection. Point of intersection. Point, note down. The point of intersection, student. What will happen? The point of intersection of 2 reflected rays of 2 reflected rays, at least 2 reflected rays. Then, because there are more rays, we are using 2. Of at least 2 reflected rays gives me the position. Gives the position. What will be giving position of the point object? So the intersection of at least 2 reflected rays gives the position of the image of the position of the image of point object. Therefore, we have to learn what we have to learn, how to draw the ray diagrams. All we need, this object is present, you can say at infinity. From infinity, I am bringing this object closer and closer. This is beyond C. I can put the object at different positions. For example, student, you can bring the object at this position. This is C. You can put the object here. You can bring the object here like this. You can keep on changing the position of the object. As you keep on changing the position of the object, you have to find where the image is formed, what is the size of the image, whether it is real, virtual, or inverted, or whatever is. So we will use 2 reflected rays. 2 reflected rays, which will give the position of the image of the point object. Note down everything. Let us see what are the rules which will be used. So we will be applying certain rules for the concave mirror. First of all, let me see. I'm talking of a concave mirror. Here is an activity you can do. You know a concave mirror, how to find the focal length of a concave mirror. You already know this activity you can do. As I have drawn the diagram, there is a pole, there is a focus and center of curvature. The rays which are parallel to the principal axis, they meet at a point which is called the focus of a concave mirror. So you can use a candle and see where the and also then you can shift the position of the candle and study what type of images are formed and what is the position of the images. Here, this activity you can do as has been shown and asked in the NCERT book. Here, what we are going, student, if you will perform an activity, the nature, position, and size of the image formed by the concave mirror depends on the position of the object. Important point. P, F, and C. What we are saying, if I have a concave mirror, and what type of image will form? It says the nature of the image, position of the image, and size of the image. 3 important points I'm telling you. This is my object, student. And if I am putting this object, what I'm saying, this is my concave mirror, student. And what we are saying, student, supposing this is our pole, this is a principal axis, this is my focus, this is my center of curvature. So what we are saying, if this is an object which I am representing by AB, this is the head and this is the bottom of this. Now the question is, what type of image will be formed, where it will be formed, where means what is the distance of the image from the pole. This is the pole. The activity which we told you in the last slide, where you can use a candle and put it before the concave mirror and you can change the position of the candle and you can use a paper as a screen to find where the image is formed. What you will observe, student, that the position of the image, size of the image depends on the position of the object. This depends where the object is, position of the object from this point, pole. If I keep on changing the position of the object from the pole, the nature, position and size of the image changes. What changes? Nature of the image, position of the change, size of the. Size means how big or how small, position means where it is formed, in front of the mirror or behind the mirror. What is the distance of the image from the pole? Distance of the object from the pole is called u. Distance of the image from pole is called v. F is the focal length, f, which we already explained to you. Nature means whether the image is real or virtual, and whether the image is inverted or erect. So all these things, what we told you, images can be virtual. What type of images we have shown you, student? What I'm trying to tell you, student, the images can be real, images can be virtual. And you know, real image can be taken on the screen. Yes or no? Virtual image cannot be taken on the screen. It cannot be taken on screen. And you see the position means from the pole, what distance the image is formed. Size means the size, it can be enlarged or it can be diminished. Enlarged means the image become larger in size. Diminished means image becomes smaller in size. This is the object. And enlarged means this has become larger. Diminished means image has become smaller. This object, AB. So here you can say A dash, B dash is the image. Here A dash, B dash has become diminished, smaller in size, larger in size. And whether the image is inverted. Inverted means it goes like this. The head comes down and this is the tail. If it is erect, student, what is erect means? Upside, turn up, upside. So head is on the top and bottom as it is. So it can be inverted, it can be correct. So all these observations can be observed by performing an activity as shown in the NCERT book by using a candle and the mirror, and you can use a screen of paper. And what you will find, the images can be, it is found to be, the image formed is real for some of the position, it is found to be virtual for other. The image is either magnified, reduced or has the same size depending upon the position of the object. Already it is clear now, it is not like a plain mirror. Is it clear? Yes or no? That the nature of the image, size of the image, position of the image will depend on what factor, student? What it depends when I have a concave mirror? It depends on the distance of the object from the concave mirror. Now the question is, how will we draw the ray diagrams? So we have to learn, student, to draw, the questions will be asked on this, very important, to draw the ray diagrams for images formed, images of objects by concave mirror, student. So before we start drawing, I said we will take two rays, minimum of two rays where they will intersect. That will be the point of image formation. From the head, this is my head, this is my bottom. If I am standing before the mirror, I will use the rays from my head. And I will see the two rays, how they go from the concave mirror. When the rays are reflected, what are the rules which I will use for drawing the ray images? Now I will tell you that. Once we learn the rules, it will be easy for us to draw all the images. Can I proceed further, students? Tell me yes or no. Is it clear? Yes. What we are going to do? We are going to teach you how to draw the ray diagrams when objects are moved from far away distance to near distance from the pole of a concave mirror. All right. The more practice we will do, student, the better it will be, because in the exam they will ask you to draw the ray diagrams. So students, what I'm saying, representation of image formed by spherical mirror using ray diagrams. What are the rule of image formation? Rules. First rule, student, note down the first rule which I can use for drawing the ray diagram. A ray coming parallel to the principal axis is reflected through the principal focus of the concave mirror. Try to draw the ray diagram. Very important first rule. I am saying, student, how will you draw on your piece of paper? Try to learn to draw the concave mirror. This is my concave mirror. My drawing may not be that perfect, student. Here you draw the principal axis. What is this? Principal axis. And the center of this is called the pole. Okay? Any doubt you can tell me. Take the scale. You have a scale, student, scale. Supposing with the scale, I take 2 centimeters. That will be focus. Then another 2 centimeter will be C. Focus is how much? Half of this. This distance is half of the center of curvature. Is it clear? Tell me yes or no.
Yes, sir.
I'm saying if with a scale you will draw 2 centimeter, you will draw another, there will be center of curvature. What is the first rule? Any ray which is coming parallel. What do you mean by parallel to the principal axis? This is the principal axis. Draw a ray parallel to the principal axis. This ray is parallel to the principal. Where it will pass from? Focus.
From the focus.
Then you draw this ray. Can you draw it now? This is my first rule. Minimum 2 rays are required where they intersect. Then I will get the position of the image. Out of the 4 rules which I am going to tell, I will use 2 rules, whatever are the best for me to draw the ray diagrams. First rule is clear, students. Note down, and you can draw it. First rule is done for the concave mirror. Similar rules are there for convex mirror also when we come. The second rule says, rule number 2. Okay, for the concave mirror, I am drawing for the concave mirror, student. The ray of light, this ray of light is passing through the principal focus. Can you see the ray of light passing through principal focus? Yes or no?
Sir.
It will become parallel to the principal axis. This is the reversibility of the light. Law of reversibility. In the first case, parallel ray passed through the focus. In this case, the ray passing through focus will become parallel to the principal axis. So how will you practice, students, and draw it? You can draw. Keep on drawing with me, students. Practice makes a man perfect. Can you draw the concave mirror now? Can you draw a principal axis? What is this point called? Pole. With the scale, you have F and double of this as C. So what you are saying, student, any ray of light passing through the focus. What will happen to this? It will become parallel to this principal axis. Can you draw a line parallel to the principal axis, students? Like this. Is it clear? Tell me.
Yes, sir.
Can you draw it? Because for drawing the images, we will need at least 2 rays. These are rule number 2. You know, even there is a reason why it happens like this. Because students, you have been told the laws of reflection. In the laws of reflection, what I told you, that when a light is reflected by a polished surface, what happens? The angle of incidence is equal to angle of reflection. And how do you draw? If this can be considered a small part of the concave mirror is like a small plane mirror. So if I draw the normal to this, where will be the normal? This will be the normal, right? And then this angle has to be equal to this angle. This is the incident angle. This is the reflected angle. Do you see that? That is why the ray becomes parallel to the ray passing through focus becomes parallel to principal axis. Rule 2. Note down. Noted? Can I proceed further? I am trying to show you.
Yes, sir.
In very simple way, I will tell you, and then you will be able to draw all the diagrams. Rule number 2. Now, student, I am coming to rule number 3. Rule 3, students. Rule number 3. Rule 3 for the concave mirror, students. We can draw the same things for convex mirror also. Convex mirror is a divergent mirror. Concave mirror is a convergent mirror. We already shown you both these mirrors in our previous YouTube lectures. Concave mirror. Okay? If a ray of light which is coming through center of curvature is reflected back along the same path. This is the focus, pole, and double distance center of curvature. If the light is passing through center of curvature, what happens to it? Reflected back along the same path. It came here, where it will go back in the same direction. Do you see that?
Yes, sir.
So this is our rule number 3, student. How will you draw it? Again, I said you have a principal axis, student. You draw the concave mirror, students. Now you know this is pole with the scale 2 centimeter focus, and drawing another 2 centimeter will be center of curvature. Sometimes it is when we draw the images, some errors take place. So you can use a trick that you already know it. That is called a cheat trick. A cheat trick that I can draw the ray diagram first and then I can make the center of curvature. I know what will happen. If it is at center of curvature, it comes like this. It goes back in the same direction. Clear? Why it happens? Because this is the normal to the, this becomes normal to the mirror, student. In the plane mirror you have seen. If a ray of light is parallel, perpendicular to this, what happens? It goes back in the same direction. That is a 90-degree angle or 0-degree angle of incidence. Angle of reflection is also 0 degree. Did we show you for plane mirror angle I equal to angle R? Got it?
Yes, sir.
You will be able to draw this. Rule number 3. Note down everything. Now the things will become very easy for us. You will be able to draw all the diagrams. Let me sip water, student. I always say, oh water, heal me. I sip water. Sipping of water, 75% of my body is water. Water has energy. Energy, it heals me. It heals me. All right, student. Proceed further. Now I'm coming to the 4th rule. Rule number 4, students. But it says a ray of light is incident on the pole. This is my pole. If a ray of light incident on the pole, it makes an angle theta. With the principal axis is reflected back with the same angle theta. If a light is coming and falls on pole, what will happen, student? It will be reflected, and you know the law of reflection holds true for all mirrors. We told you very clearly. This angle of incidence is equal to angle of reflection. This is my 4th law. How will you draw it? Make a concave mirror. Make a concave mirror, students. Learn, learn, learn. This is my pole, students. Again, I have a focus and double the distance. See, the ray of light is falling at the pole. Incident. This from the object. From the object, I will take this ray of light. There is no need of this. Okay. From the object. When it falls, students, at the pole, what will happen? It will get reflected, and this angle will be equal to this angle. This is angle I, this is angle R. This angle I is equal to angle R. These two angles will be equal. Pole, focus, and center of this rule I will use very less. But other 3 rules I will use a lot in drawing the ray diagrams. Is it clear?
Yes, sir.
How many rules I told you? Tell me.
4.
4. All are easy and learned. And this is not the one which I will be using. It is not required. The first 3 will be used. Now let us see, students, how we can apply these rules for formation of images by the concave. As I said, as you seen in the activity, when the distance of the object changes, from the concave mirror, the nature of the image, the size of the image, everything changes. Position of the image, all this is what we want to find out. So students, first I am taking first case one. Case one. What is case one? We are talking of image formed by concave mirror. In the case one, student, I am saying the object is placed at infinity. Where is the object? What do you mean by infinity, student? Farther away. Farther away. Object is far away. Infinity means object is far away. That is what it means. Yes or no? What will be the position of the image we want to find out? What we want to find out now? What is the position when the object is at infinity? Our object is at infinity. Okay? What mirror I am talking about? Concave mirror. If there is any doubt, you can ask me, student. Object at infinity. First thing we want to know what is the position of image. Second, you want to find the size of the image. And third, the nature of the image. These are the three things which we want to find out. Am I right? Tell me.
Yes, sir.
Okay. Now, as I said, an object will be taken like this. AB. This is the top head. What is this? This is the top head, student. If the image is like this, then that is considered erect, upright. If it becomes reverse, A comes down, B comes lower, then we call it is inverted. Inverted. Let me see what will happen, student, and how will we draw the ray diagrams. You already know, student, when the rays are coming from infinity, infinity means far away distance, they become parallel to the principal axis. And when the rays will come parallel to the principal axis, students, what will happen? Tell me, what rule I am using? Infinity means rays are coming parallel, object is at infinity. When the rays will come from the reflected rays will come from the object from infinity, they will be parallel. They will be parallel on the concave mirror. And when parallel rays will fall on the concave mirror to the principal axis, where will they meet? Tell me, where will they meet, students?
Sir, at the principal focus.
At the principal focus. And then that will look like a point object. But it will be just like a point object. Point size. That means the size of the object has become a very, very diminished. How diminished? Like a point. So here we have shown here, student, what I am saying, that this is my focus, this is my center of curvature. Now I am saying, okay, farther away, infinity. At infinity, student, I have an object. And I'm representing this object as A and B. Now what happens, student, when the objects are at infinity, student, what is happening to the object? Then you already know that the rays of light will become parallel to the rays of light are coming parallel to the principal axis. And the result of this will be what? Let me show it in a better way here, because this is at infinity. So let me put it like this. Supposing this, it looks like this now. This is my A, B, student. What will happen? The ray of light, this I am showing dash because it is at a farther distance. So when they come near to the concave mirror, they will be parallel. The parallel rays are coming, student. Parallel rays are coming. Okay? Parallel rays are coming. Or where they are coming? On the concave mirror from this object. So what is happening now? Where will they meet, student? They are going to meet at the focus. At the focus. So what you will see at the focus? A point object, point sized object at the focus. Therefore, what is the position of the image, student? Tell me, what is the position? What is the answer? Position of image. Where it is formed? At focus. F. Clear? Size of the image. Point sized. Point sized mean Diminished. ठीक है? How diminished? Highly diminished. Highly, very small. Highly diminished, I am saying. And what type of image is there? Whenever you are getting an image which can be taken on the screen, student, what is this type of image? This will be real and inverted. What you will see, the point, the B will be up, A will be down. What do you mean by that? It is something like this, student. The A comes down and B goes A, B dash A dash. You can see inverted. But you're getting point sized. These images are real and inverted. Real and inverted. Is it clear? Can you draw this in the exam? Any doubt? This was the case one. So when the object is at infinity, the position of image is at focus, it is point sized, highly diminished, and nature of the image is it is real and inverted. Real images are always inverted, virtual images are erect. We learned that. Yes or no? We learned it because in the quiz question paper I will ask all these questions. Real image is inverted, virtual image is erect. Clear? Case one done.
Yes, sir.
Now I will start moving the object closer and closer to the concave mirror. The activity which we did with the candle in the physics lab, in the science lab. And how will we draw the image? Let us go to the case 2. Now students, I am coming to case 2. When object is beyond C. Object beyond C, students. What it means? Object beyond C. You can draw this on paper. Pole, focus, and center of curvature can be drawn. Any difficulty in this now? Tell me. We have to learn it. Practice. You have to practice this to draw it because that's very important. How will I draw this mirror? You know, this is my mirror. Principal axis. If I take the scale, you can take this equal to this 2 centimeter. So this is my focus. This is my center of curvature. Now where is the object? Beyond C. It is not at infinity. Infinity is a very far away distance. So beyond C, student, this is, if I put it here, okay, this is beyond C. Tell me, is this object beyond C? Yes or no?
Yes, sir.
Maybe. Now I have to draw the ray diagram. How many rays are required? Tell me. What I told you. How many rays you need to draw a ray diagram?
Sir, at least 2 rays.
2 rays. You will need 2 reflected rays. This object will reflect the light. You will need 2 reflected rays. Okay? And I always take these 2 reflected rays from the head. Where is the head? This is the head. Okay? This is my head, student, arrowhead. Okay? I will use this. Although there are infinite number of rays reflected, but we will need only 2 reflected rays. So if I use rule 1, what the rule 1 says? Tell me, what is rule 1, student? How to draw? We are going to, in the exam he says, draw the ray diagram when an object is beyond C for a concave mirror. Draw the, question is like this, draw the ray diagram. Okay? When object is beyond C. Beyond C for a concave mirror. Okay? So, and tell me what is the position of the object, position of the image, size of the image, and nature of the image. Tell me what is the first rule? The ray of light which is parallel, student, to this will pass from where? It will pass from where, student? Tell me. The ray of light parallel to the principal axis, rule 1. I am using rule 1. The ray of light parallel to principal axis will pass through which point? Focus. This is the focus, student. Am I drawing maybe a little bit? This try to draw by the scale. You have a scale, you can draw by. Okay? Is it clear? Did I draw the right thing?
Yes, sir.
Now, what rule is easier for me in this case? It looks to be easy that if I use rule 3, what was that rule 3, student? That the ray of light passing through center of curvature. What happens to that? It is reflected back along the same direction. Am I right?
Yes, sir.
Now, are the two rays intersecting at any point?
So between F and C.
Very good, very sharp student. Now you will do it so easily. That was my idea. That was our idea, student. You can easily do it. Okay. Now this is the point of intersection, student. What has happened? I have used the head. Now the head has come down. Okay? What is that? I'm saying A is A dash now and B is B dash. You get this image. This is the image. It is found between F and C. F and C. So here is another picture to the scale, because this is not to the scale. I have drawn it without any paper, any scale. You can see the first rule I used. This is the first rule. This ray of light is parallel to principal axis and passes through focus. Second is pass through C. This distance and these are equal. C P as PC is 2 times of PF. And it is reflected back, and you can see this is the image formation, student. This is the image formation. Now we can give the answer to this question. What is the answer, student? First thing we want to say, what is the position of the image? When the object is beyond C, what is the position of the image?
So between F and C.
Between F focus and center of curvature. Second question, what is the size of the image? Larger or smaller, or is it bigger or smaller?
So smaller.
What we call it in physics? Diminished. Image is diminished. Very good. And what is the nature of the image, student?
So real and inverted.
It is real. Real means if I put a screen here, I can take it on the screen. You can put a paper, it will come there. It is real, and real images are always inverted. This is our answer for case 2, student. Question number 2. Is it difficult to draw the ray diagrams? Now tell me. Exam, concave mirror, you have learned so well. Okay? Then I will proceed further. Okay, students. All right, student. We're coming to the next part. Case number 3, student. When the object is at C, what is C? Center of curvature. Imagine that you are the object. You are coming now. You are the object. You are coming toward the center of the curvature. Now you are standing at this point C, students. This is the point, student. Okay? And this is what I'm saying, student. This is my A, this is my B. So he says in the exam, object is placed at center of curvature in front of a concave mirror. What is the position of the image? What is the size of the image? What is the nature of the image? Draw the ray diagram. How many rules I told you? 4 out of 4 I said last time. Don't use, I use first, second or third. So let me apply the rule. Always first thing I apply the rule 1. What is the rule 1? The ray of light which is parallel to the principal axis will pass from which point, students?
So it will pass from the principal focus.
It will pass from the principal focus, student. Now, in this case, student, we already know that a image will be formed which will be real inverted at the center of curvature. So sometimes in the exam, when we try to draw, things are not to the scale. But if I know already, then it becomes easy. What I use a cheat trick that I already know where the image is, what is the nature of the image. Then in such case, what I do, student, I am using a cheat trick that I already draw the image of this. It will be like this, student. The image is already known to me. This line I am taking. So what will be this? You know, this is my B dash. The top is coming on the bottom on the top. So this is the first ray which I have shown, student. First rule that this ray which was moving from here parallel to the principal, this. And second, in this case, what I will do, student, rule 1. What is rule 1? Ray which is parallel to, let me, because sometimes if we write, if we remember, then it is easier for us. Ray parallel to principal axis passes through focus, right? Passes through focus. And then I am saying what is now I am using rule 2. The ray of light which passes through focus, ray which passes through focus will become parallel to principal axis, right? Did I tell you this rule?
Yes, sir.
In this case, it is easier, student. What I will do, that I will draw this line. And now it will become, already I have shown you this. So the ray passes through focus, it becomes parallel to the principal axis and you get this image. And here we have shown it to the scale, student. This diagram, AB, the ray parallel to the principal axis passes through focus. The ray which passes through focus becomes parallel to the principal axis, and this is the image which you are getting, student. So what is the position of the image, student?
Sir, at the center of curvature.
At C. What is the size of the image?
So same size.
Very good. In the exam, how easy it will become. What is the nature
Real and inverted.
of image? It is real and inverted. Real images are inverted, virtual images are erect. Very good. Very good, student. How effectively we can apply the rules. Okay, note down everything. This question has been asked so many times in the paper. I will tell you tricks, ray diagrams. By using rules, we can easily draw. You will never forget them once you start drawing it. All right, students. Let us go to another case. Now I'm coming to students. We have case next, student. How many we have done? How many we have done by now? 3. Case 4. When object is between student C and F. When if I put the object between center of curvature and focus, then we have to see what is the position of the image, size of the image, and nature of the image. All right, so student, how will we use this? This is my focus and this is C. Your object is at this point. What is this? A and B, students. First rule, always I am using parallel to the principal axis. It passes from where?
So from the principal focus.
Focus, student. Okay, this is the first rule I use, student. The second, in this case, I can pass the ray from the center of curvature, student. what will happen if I pass it through center of curvature, students? If it passes through center of curvature, it is reflected back along the same axis. So I will use rule parallel to the principal axis, passes through focus. When the second ray passes through center of curvature, it will be reflected back. Where they are intersecting? Where is the point of intersection, students?
Sir, it is beyond C.
All right. So what you can see that this is the point, student. What you are getting? This A is now A dash and this is B dash. So we have already learned so well, we don't need to explain you each and everything again. So the question which is there, question was draw the ray diagram when object is between C and F for a concave mirror. Okay, students. So what is the position of the image? Position of the image where? Beyond C. What is the size of the image?
Sir, it is larger than the original image.
And it is what we call enlarged. Size has become larger. And what is the nature of the image?
Sir, real and inverted.
Real and inverted. So by that way, student, we answer the complete question. Here is a diagram to the scale. This is the object AB and how you can see a ray parallel to the principal axis goes through focus, and the ray which is going from the center of curvature will be reflected back. It will also be like this. To the scale, if you will draw, student, what will happen? So this is the to the scale. If you draw, it will be a straight line. Then you can see. So this is the to the scale we have drawn it. So we should be able to draw the ray diagrams in the exam. By drawing ray diagrams, we get full information of what type of image will be formed, what is the nature of the image, and the distance of the image from the object. All right, student. Case 5 is coming now. Case 5. If object is at focus at F in front of concave mirror. But a mirror I'm using concave mirror. What will happen now? I am putting the object here, student. This is my A and B. So first I always use a rule number 1, and you know what happens, student. It passes through the focus. Ray parallel to principal axis passes through focus. Now F and C are at equal distances from here. So if I will pass the second from the center of curvature, what will happen, student? It is to be reflected back. Okay? It will go here and will get reflected back, student, in the same direction. Now you can see that they are parallel. They will be meeting somewhere at infinity. Where will they meet? These rays look parallel, student. Where will they meet? At parallel rays meet where? They will meet at infinity. The rays are going to meet at infinity. And what will happen then? Then it will be highly enlarged image. Highly enlarged image. So again, we can write, student, the question, when object is at F in front of concave mirror. What is the position? What is the position of the image? Where it is formed? at infinity, farther away distance. What is the size? Highly enlarged. And what is the nature? When it is formed in front of the mirror, what will happen? It will be real and inverted. Is it clear, students? Note down. Noted?
Yes, sir.
All right. Coming to the last part, which is case 6, student. When object is between, this is my pole, between P and F. Object between pole and focus, student. What will happen then? This is pole and focus. A and B, student, A and B. How will we draw? First rule, parallel to the principal axis, where it passes through the focus. First rule. Second, if second ray passes through center of curvature, then what happens, student? It is reflected back along the same direction. Now they cannot meet in front of the mirror. Can they meet in front of the mirror? Tell me. These rays are diverging. They cannot meet. Then what we see, they will appear to meet, student. Then I'm showing dash line, dotted line, dash line. Somewhere on the back, student. What is happening now? You can see, if you draw to the scale, student, what is happening. I've shown dash line. They are meeting at this point, student. So AV, how it will appear? But how it is appearing, student? You can see that. What is happening? Now you see the image.
Yes, sir.
What type of this A dash, B dash. What has happened to the image, student? It has become enlarged and it is behind the mirror. So position of the image behind the mirror. It is enlarged, student, and now it is virtual and erect. And you know that now it becomes clear the use of concave mirror for the shaving mirror. Shaving mirror, we put our face in front between pole and focus. It will be a larger image, virtual image, and erect image. When you want to put a lipstick, you use a mirror, concave mirror. Does your image become inverted? No. And that is a virtual and erect and larger image. What mirror we are using? Concave. Dentists are using these mirrors. What happens? Image become enlarged. Larger in size, yes or no?
Yes,
so
sir.
we can draw the images. Now images can be drawn, student. Any doubt?
No, sir.
Okay. So we already know what type of images are formed. And let us see some of the uses of concave mirrors. They will ask you these question. Question has been asked so many times. What are uses of concave mirrors? Very important topic. I am saying they are used as shaving mirror, just as I told you. Why shaving mirror? Because if object is between the pole and focus, what will happen? Image will be between P and F, what happens? You have seen. What type of image is it? Magnified, enlarged, virtual, and erect. So in the cosmetic headlights of torches, what happens? If light is coming on the focus, it will give the rays of light will become parallel to the principal axis, and you will see torches and headlights. They give the light, reflected light goes strong and at a longer distance. Optical instruments in medicine like ophthalmoscope used to condition of eyes. ENT specialist, you have gone to some ENT specialist, you know, they use some mirrors. So they are able to see the virtual and erect and magnified, enlarged images of the object. Then you have seen two dental mirrors, dental doctors and solar furnaces. What do you mean by solar furnaces? If I have a concave mirror, if light is falling, parallel rays will converge at the focus. When all the rays of the will come at the focus, what will happen? Sun rays are focused, so they will produce a lot of heat at the focus. So it can be used as a solar furnace. Satellite dishes and visual bomb detectors use concave mirrors. You have seen satellite dishes on your home. It looks like a concave mirror. Yes or no? Seen concave in shape? You have seen those antennas, satellite dishes. So all these are the uses of the concave mirror. So we end up the important topic of how to draw the ray diagrams of concave mirrors and what are the important uses of concave mirrors. I hope there should be no doubt, students, how to draw the concave mirrors, and you will subscribe our YouTube channel and also ask your friends to subscribe it and watch the YouTube videos, because this provides complete and clear-cut information and easily by the rules which we have shown you and the way we have drawn the ray diagrams. You will be able to draw the ray diagrams for any object when it is moved from infinity towards the pole of the concave. Is it okay? Yes?
Yes, sir.
All right, at least you will forward it to 5 to 10 friends so that they can take benefit of it. We have to work very hard for giving these lectures, because we want to give you the best of the best so that you can do and answer all questions and understand all types of science behind the laws which we are talking about, laws of reflection and the light. The chapter of light is very important and very, very useful, and it must be understood very, very clearly. Okay, then I will see you in my next class. Bye-bye.
Thank you, sir.